Do you want to know how Microsoft Copilot and Cursor helps you write code? In this video, I'll break it down for you and let's go! So I'll go through how I built Kevin. Kevin is an enterprise AI programmer. We use this when we build enterprise systems. Essentially, the problem we're trying to address is that enterprise applications are complex. They need compliance, you need reusable codes, you need to do a lot of code structure and standards, including code review. And enterprise applications needs predictability. In order for your codes to be maintainable, they need to be predictable. And enterprise applications are big. They require a large team to build. And yet, everybody is just copy and pasting. You copy and paste codes from your You copy and paste code so that you'll be able to establish standard coding structures. So Kevin is essentially an AI assistant that writes the codes based on your examples. It will be able to write code that follows your structure, that follows your architecture, as well as checks for errors and warnings. Essentially, it writes the boilerplate codes for you. But this session is not about Kevin. This is about how we can build something like Kevin. So I'll walk through the code and show you how we built Kevin and how it helped us improve our development time. The best part is Kevin is here, it's open source, it's available. You can scan this QR code or go to this URL and you'll have access to Kevin, your AI pair programmer. Kevin also runs on your local machine or your local environment, so you do not have to expose your source code to the public cloud network. Okay, so once you're able to download the code in the GitHub repository, you should be able to see the Kevin tutorial notebook. So we'll go through this code, which explains how you can possibly build your own AI pair programmer. So we start off, of course, by installing the required libraries from LangChain and OpenAI. And then we set up our OpenAI API key. So the first prompt is we are trying to invoke the OpenAI library. So to invoke an OpenAI library, you need to set up your system prompt. So in this case, the system prompt is that you're setting the behavior of the system. You're telling it that you are a funny programmer. You give clean code. You can crack some jokes and make technical topics more interesting. Keep your response short. And our prompt is hello, how are you? So this is just a simple way to test if we're able to integrate with the OpenAI library. So it says, I'm doing great, thanks. Just like a well-optimized algorithm, I'm running smoothly. How about you? Ready to debug? Right, so now we're able to invoke that, but that's not what we're going to use in this exercise. Instead, we will set up our own local LLM using Ollama. So to do Ollama, you have to install the Ollama version here, and you set up Ollama, and it will download the Llama 3.1 model. So most likely, if you're running on your local machine, this will install a quantized version of Llama that runs on local computer. So you don't need like super computer GPU to get this running. Of course, take note, with quantized version, you will get a lower quality of LLM, but nevertheless, we'll be able to show you that it actually works. So once you have downloaded and initialized your Ollama, you can then start sending it messages. Similar to how we did the OpenAI, we are invoking it with a system prompt and a message, hello, how are you? We're merely changing the class instance to use Ollama instead of OpenAI. So let's invoke that. Now notice that this takes some time, about 3 seconds. It's much slower because it runs only on my local machine. But it also responds. I'm coding along just fine. Thanks for asking. Or should I say, compiling along, right? So it tries to get funny and greet you as you requested. So moving on, let's ask the LLM to write some code. So basically what we're changing is we're changing the system prompt. You are telling it this time that you are a TypeScript programmer. You write clean code based on coding standard, respond with a complete line of code, and apply the change. So you specify what you want to respond, but this time we are also telling it to indicate what is the file name, to give the file name and return in this format. Right? So you specify that in the system prompt, and then you send it an instruction to create a login page with a form that has email and password fields. So now we call it to our local LLM. It will then create an HTML code that is based on your instruction. It has to be clean code, it has a login page with email and password, and it will also indicate the result in this file name format. Okay, now we see the result. The response starts with the ## file name, and this is the file name, and it indicates what type of file should be inside. Essentially, when we send the prompt instruction to the AI, it then of course respond an HTML code. So the next thing to do is to actually parse this result. Because it follows a certain format, we'll be able to identify in what file name should we save it and what type of file it is. So in the next few lines of code, we then started prompting the result and creating and writing down the file. So this logic basically breaks down the file and saves the file into this location, pageslogin.txt. So now we have the file automatically created. Now we can also ask the LLM to update existing code. So in this case, we're sending the same system prompt, but instead we are changing the instruction. We tell the instruction to update the email to username and a certain parameter where the files are. Now what happens here is that we change the instruction to the model by changing the instruction to updating of email to username, but at the same time we are going to send the source code. So which means we will read the content of the file, plug it into the AI, and tell it to update the exact file. So when we now run it, right, we read the file here and then we plug the actual file contents in this location, and then we should see that it now changes the email to username. So now you see the concept, right? You send the prompt to the AI sends a response, you ensure that the AI responds in a specific format, you parse the result, and you do something with it. In this case, we're saving it to the file. Now the next step after this is that you can actually do a lint check. We'll check for warnings or errors that has been generated by the AI. So this is the piece of code that will essentially run a lint check on the command line, and then we will get the result of the lint check. So once this is run, this will then check for potential errors. There is this error, this case number, it's included, right? So there's an error and there's a warning error. If you are able to get this warning from your lint check, you can then read this file, use case form state.ts, right? Send the warning error to the LLM, let it correct this error, and then save the file all over again. So now the AI automatically updates, and so now the AI automatically fixes the errors based on the lint check results. So let's do it now. This piece of code actually parses the result of the lint check, so we should be able to see what the error message is, right? So we parse, this is the file that is causing the warning, and this is the warning of the code. So we can then print the file, and let's now set up the command so that we'll be able to send the message. We'll be able to this one extracts the result and the right codes to file. So these are just utility functions that will simplify our parsing and processing of the source codes. So now we tell Ollama that you are a programmer, you will fix this issue, right? When introducing new lines of code. So you have to specify certain prompts here so that you can get the expected result. Again, we tell it what the format of the output is, and then we read the lint issues and we give it the code, right? So it's the same logic. You give it instructions, you give it what the error is, and then a copy of the source code, so it will then give you the corrected code. So once we are able to execute this, you'll then get a corrected response based on the lint check error and save the file again. So essentially that's how code correction works. You prompt it to the LLM, you integrate it with certain kind of functions or tools on your machine so that it can be able to perform the necessary steps that are needed to accomplish a certain task. So that's essentially how GitHub Copilot or Cursor works. It integrates LLM into your IDE so that it can update the code based on the response of the LLM. Basically what we're doing is we are prompting the LLM for a better piece of code and then automatically put the code into our IDE. In this case, we are saving the code into the file. So depending how you want to interface with it, it's the same concept. You send the instructions to the LLM, get the updated code, save it somewhere, and make our life much easier. I hope you have learned something from today's coding session. Please don't forget to click like and subscribe. This has been Artificially Intelligent.